Welcome back, everybody. Today we are going to be putting into practice some concepts of specific heat. We know that specific heat is the amount of energy it takes to raise the temperature of something 1 degree. And so the item that we're going to be finding the specific heat for today is going to be this chunk of copper. So the idea is, in a lot of the other problems on our worksheets, we have been trying to use specific heat to determine the amount of heat is going into or out of something, but this time we're going to actually dump some heat into this, and we're going to basically see how that all works out. So our source of heat is going to be some boiling water. So we've got some boiling water over here. The idea is we're going to put this into the boiling water, and that's going to allow it to absorb some energy. Then what we're going to do is, once this has a lot of energy in it, we are going to let that energy escape, and we're going to basically see how much of it escapes. And so it's going to escape into something that we can measure the temperature of, because while we have this piece of metal, if you're just trying to like put a thermometer up against the piece of metal, that's not going to be a very good temperature. So we measure it indirectly, and what we do is we basically will drop this into water. So we're going to get it warm with hot water, and then we're going to put it into cold water, and we're going to measure how that water changes temperature. This process is known as calorimetry. So over here we have a couple of styrofoam coffee cups. So I'm just kind of nesting two of them together, and the idea is that this will trap all of the heat inside. So when we're looking at our substance, any heat that comes out of this piece of metal should go into the water in this cup and be trapped there. It can't escape into the surroundings. And then the amount of heat that goes into that water we'll be able to measure with our thermometer. So to do that, we need to get a couple of measurements right off the bat. The first thing we need is the mass of our copper. So we're going to go ahead and record that. I need to get a pencil. All right. Okay, so we've got the mass of our metal. The next thing that we need to do is get the mass of the water that we're going to be using to trap the heat. Now, in this situation, we don't really have to put the water onto the digital scale, because when we're dealing with water, 1 gram of water is equal to 1 milliliter of water. That's what density basically is. And so if we take a look at our graduated cylinder here, you're not at the right angle for it, but I measured this thing. This is 40, this is 50 right here. So we're actually spot on 50. I was really careful to get exactly 50 milliliters of water. So we're going to go ahead and put the 50 milliliters of water into the cup. And we're going to get an initial temperature for that. So we're going to go ahead, place the thermometer into that cup, and we're going to let that thing sort of come to equilibrium. We want to wait for the temperature to be pretty constant. And then we're going to record that number. While that's doing that, we need to go ahead and get our metal warmed up. So over to the side here, we have the boiling water, and we know that from our heating curves, once water begins to boil, the temperature remains constant. It will always be the exact same, and we know that that temperature of boiling water should be 0. So what we're going to do is we're going to put the copper down into the beaker here, and we're going to let it sit in here for about 5 minutes. So at the end of 5 minutes, the metal in the water should be the exact same temperature as the water, and we can then assume that our metal is 100 degrees. We can then take the metal out of the beaker, put it into our calorimeter, and we can see how this temperature changes, because the metal is going to start dumping its heat into this and changing temperature. So Right now we can see that the thermometer is evening out here. So I'm not sure if we could see that okay or not. Looks like about 23.4. And so I'm gonna let this thing sit and I'll come back in about 5 minutes. So the metal's been in the water for about 5 minutes now. So we're gonna go ahead and fish the metal out and we're gonna put it into the cup. And we're gonna observe how much the temperature changes here. So let's just try and get some of this out of the way here. So we want to try and move it in there as quickly as possible so we don't lose too much heat. We want to try and observe the highest temperature that we get here. So we're going to go ahead and just swirl this around a little bit. Looks like it's starting to go down a little bit now, so the 30.3 was probably the highest temperature that we're going to get, and from that point we're just going to start losing a little bit of heat from the lid here. It's not doing a perfect job of trapping the heat, but 30.3 seems to have been the highest temp, so that's what I'm going to go ahead and record.